Hey, everybody. So if you're watching these videos for CTK 460 in the fall 2022 semester, just make sure you've watched the XR setup video before this. This actually won't have any XR stuff in it at all, but I'm sort of building on those concepts that you're going to see when you're doing interactions and stuff like that. So this sort of fits in the middle of some other videos, but is obviously really relevant to any kind of Unity dev in any capacity. Okay, but just thinking about this continually as a series, right? So what we're doing today in this video is just talking through physics in a really basic sense of what the physics interactions are like in the Unity engine. Obviously, it's a huge topic, right? And I'll probably make successive videos later, or we'll talk in class for sure, about how to tweak these things. And you can go into like really deep engine level physics manipulations about gravity and drag and air and all this kind of stuff. But for us, we just kind of want to wrap our heads around what it is, how it works. And then in the next video, I'll show you how to apply those things to your XR kit and the interactables. So in a neutral kind of scene here, I just started a new scene, new project, or same project, new scene, rather. You have a camera and you've got your directional light. I'm going to make an object over here. I'm just going to create a primitive, and we'll create a sphere here. And there it is. We can see it in the game view. It's at 0, 0, 0, and it's set up so we can view it through our camera. I'm going to make also a floor, just like kind of plain underneath it, like that. And then I'm going to move my sphere up just a little bit so it's not in the ground, right? And just move it in here with my camera. And I showed this in the first class that we met. And if I didn't, here it is again, or here it is for the first time if I didn't show this. But if you want to move your camera to view, to the view of what you're seeing in your inspector, you can do that by clicking on your camera. Right now you can see it's like, this is what my camera's seeing. And then go to game object and then align with view. And now it's like the camera is basically here. It's looking at what you're viewing. Really helpful for doing just stuff like this, though there are other, obviously applications you'll start to see. Okay, so we've got the sphere, right? We've got a plane, and that's it. These are two primitives. You've been playing with these, you built little models out of them, right? And that's all good. If we were to hit play and run our game right now, nothing's going to happen, right? This is the game. There you go. That's it, right? And that's fine, right? But that's not particularly interesting. We wanted to have action, life, right? We would want things to be interactable. We want to grab things, throw things, have things fall, whatever. Stuff happens, right? In real time or not real time in your experience. One of the primary ways that you enable that is through accessing the physics engine. If you click on the sphere here and we go over to our inspector, you're going to see a whole bunch of different components, right? We've talked through these in class. You've got your name and your tags that will be relevant at times throughout the class. Name always, right? But like the tags and stuff we'll talk about. You have your transform. This is showing where it is in 3D space, its size, rotation, all those sorts of things. This is almost 2 meters up on the Y. Actually, we'll make it 2 so it's nice and round. And then we have this thing called a mesh renderer, or a mesh filter here. We'll talk about these when we start getting into materials and all of this stuff. That'll be the next sort of topic in the class. We'll skip it for now, but know that these are very important because this is actually how the renderer works. It's the reason you can see this in the space. For us today, let's talk about this. And notice the coloring. This is intentional and important. That these things have different colors. These are blue, and then this is green. And these are correlating to the element of the engine that it's engaging with. Blue is going to be rendering, and green is physics. So we have this thing called a sphere collider. So what is a sphere collider, right? Well, sphere collider. Okay, so we're zooming in here, and we want to be able to see kind of what that collider is. And if you can see, it's this. You see this green thing here? That's the collider, and it correlates to this color over here. And I'm going to unclick this check mark here. And just so you know, like when you unclick things in the inspector, it actually deactivates that thing. So if we clicked on sphere, the sphere would disappear. But if I click on mesh renderer, again, we haven't talked about this yet, but this should make sense. If you click on mesh renderer, it's going to be invisible. However, what's important is the physics are still there. The green is still there. And you can see this thing, this is a collider. around it. The collider, essentially, you can think of it as like the shell or like the skin on it. It's the outside of the thing, but it's non-visible. You're not going to see it in the world. It's the thing that you can interact with, though. So if we have the mesh renderer on, right, and you think that you're grabbing the sphere, you're not grabbing the image of the sphere. You're grabbing this thing around it. Does that make sense? Like this is what you're actually interacting with, not the actual visual of it. So that's what it is, right? This, in order to have any kind of interactable with something, and you want to touch something, you want your hand to hit it, whatever, you at least, the bare minimum, need a collider. There are a bunch of different types of colliders in Unity. The ones you're most likely going to see are the sphere collider, and then I'm going to make a cube. Let's set this to 0. And then bring it over here just so you can see it. You can see that this has a box collider on it. Box colliders are very common. This is what you would see in a game. You see this all the time if you played video games. Like this, here's a big wall, right? And then turn the mesh renderer off. This happens all the time in video games because what this is an invisible wall. So if you imagine you're playing a game and you're running along and you hit that point where you're not allowed to go any further because they want to like make the whole map, right? That's your mesh renderer just being turned off, and you have an invisible collider. Okay, so you can see a lot of these. The third one is called a mesh collider. We'll talk about those when we get to them, when they become relevant. But just because they're a little bit different, and they will be relevant later in the class. But let's just talk about the primitive ones right now. So you have sphere and cube. There's also capsule collider. If you look at that here, zero this out, and we have the same sort of thing. If you zoom in and look at it, right, turn off the renderer, you can see it. Capsules in Unity as a primitive usually stand in for like a person. This is more or less a person, kind of, right? So that's what you'll see them like as like representations for humans or something like that. Okay, so look, that's what they are. That's the skin, right? If I were to turn this off, so we turned off that object is still visible, but it no longer can be interacted with. You're not going to be able to hit it with anything that's checking for some kind of physical interaction. So let's demonstrate that, right? If we were to hit play and you're like, great, we got this going, we got physics, let's go. Boom, boom, boom. Nothing happens, right? Because all this is the skin around the object. We haven't told Unity to how this object should actually work in some sort of real-time physics environment. And to do that, you need another component, which is called a rigid body. So if you type in add component, you click add component there, you type rigid, you're going to get rigid body. If you want to go back and you look through this, right, these are all the different categorizations. And you click on physics, you're going to find all of the physics stuff here, right? They're all green. And you can find rigid body. You can click on that, and it's going to add this component. Really quickly, I do want to show you, when I went back and typed rigid, there were 2 of them here. There's rigid body, and then there's a thing called rigid body 2D. For this class, for any VR stuff, we're not using 2D colliders. This is if you're making like a sprite, like jumpy, sort of game, right? Like a side scroller game or something for Switch or whatever. So we're using rigid body, which is, the 3-dimensional one. Okay, cool. So we have that now. If we hit play, it's now going to do something, and you can sort of guess, what do you think it's going to do? Now it has physics, and it's being told that it should interact with the real-time physics engine. Use your big college brain. What do you think is going to happen? It's loading. My computer's thinking really, really hard. This is shockingly long. There we go. Great. I had to really think about what it was going to do. Yeah, what did it do? It fell, right? Because now it has this rigid body, and it has mass, it has a drag component, angular drag, and it has this thing called use gravity. Do you want it to have gravity or not? And it is toggled yes, okay? Which is awesome, right? If you use gravity, it means that as soon as the awake function is called, not the awake, it's after the start, the physics calculations start. So we'll talk about that procedure in a minute, couple days, couple classes. But once you have gravity checked and you hit play, it's going to start interacting with the engine. And for now, right, it's there and it's just going to fall, which could be really desirable. Imagine like you have, I don't know, like things falling from the sky or something. It's just as soon as the game starts, they're falling, and you want them to be interactable, which is totally fine. In a VR environment, if you're making like a game, and this is your first XR assignment, will to be make like sort of a like carnival game or something. Like we're going to throw things or play with objects. You're probably going to want all of your objects that you're going to interact with to have gravity. However, in like a simulation where you're not really trying to make something hyper realistic, right? You're trying to create an environment where people can interact with things or look at objects, or like maybe like a gallery could do this too, where you're wanting to look around at 3D models of stuff. Maybe you don't want the person to be able to like knock the vase off the table, right? But you want them to be able to pick it up. You can still do that by using a rigid body in the sphere collider and then unchecking use gravity. And what this will do now is if you hit play, it's not going to do anything until you try to do something to it. If you try to grab it, it's still grabbable and you can move it around, and then let go of it and it'll just float in front of you, right? And that's super helpful for, again, like sims and stuff, I think are really good. Nursing simulation, right? I mean, I guess you could do it so you want their stuff they're working on, if they drop it, they have to like pick it up, right? But probably, right, what you want is they can grab something and work it and just like put it over here next to them and then go and grab it again out of the air, right? And use the power of VR like that. The other option here that you can do, you can click use gravity and then click is kinematic. And what this means is it will use gravity, but it will only begin to use gravity if it's interactable with some sort of scripting, something like something is going to trigger the ability for that thing to use gravity. That's generally the overarching like rigid body principle here, right? So now this is kinematic, means we can interact with it and we can trigger the gravity to be engaged some way in kind of another kind of code component. All of these things over here are playable. Like you can play with them, the drag, the mass. So for instance, if we turn the drag really high, right, and we bring this up higher, you can sort of think of what's going to happen, right? It's putting more air drag in. And it's falling extremely slowly. And they're slowly falling, right? There's way too much drag, right? Air resistance on the object. That's one way. I know in the Monday class, people ask like, how do you like make something slower, right? How do you make something move more slowly in the air? That's one way, right? Imagine like air resistance. You could also imagine mass. It might move more slowly based on the amount of force that you're putting behind it. You can also increase or decrease the amount of force that your arm has, or most realistically, a combination of all of those, right? And that's what we'll be talking about, like experimenting with. And that's what I want you to experiment with for your XR homework, right? To just play with these different components. All right, so that's the fast and dirty like physics chat. Just to recap, when you make an object in Unity, it will not come with a rigid body on it, most likely. It may not even come with a collider on it. Your primitives will all come with colliders. So if we make a cube or a sphere, your cube will come with a collider, but no rigid body, right? So it's not going to actually fall. It's actually not even interactable. It's just there, and things will hit it. If you were to like throw an object into it, right? Bring this over here and say we want to, hey, what's up, Isaac? Say we want to, I'm gonna turn teams off. Get out of here, guys. Say we want to, say we want to have that sphere land on this cube, right? That will happen if the sphere, we'll turn our drag down to 0 again. This doesn't take forever. If we want the sphere to fall, it will collide with this cube because the cube has a box collider, because it can be interacted with. However, the cube won't fall because it's not interacting with the real-time physics engine, because it does not have a rigid body. So this is super useful, right? That you could have an object like this, a little platform, right? And if we hit play, that sphere is going to fall and it's going to hit the box collider. And say now we're like, well, after a certain amount of time, we want the sphere to be able to go through the box, right, the platform. If we uncheck box collider, it's going to fall right through, right? And we'll keep going. How about if you wanted this to be like an invisible wall, right? You want the sphere to fall, and that's what you do. Again, we turn the mesh render off. We'll chat about like this workflow, but just like demonstrating, right? That now it's going to fall and balance in the middle of the air and just stop there. And again, the idea is maybe at some point then you want it to keep moving. You uncheck that. All of this is controllable through code and different interactions in Unity. Okay, real fast and dirty. I know I said we were done just a second ago. Fast and dirty physics explanation. Play with this stuff, right? The things I want you to tool around with are these different settings in here. Mass drag, angular drag. As you're making things, turn the values up, right? See if you can mess around with them, see what they feel like. Up, down, what's the drag plus heavy thing? What does that feel like to throw? Heavy thing plus no drag, light thing, lots of drag, that kind of stuff. And then we'll start to layer on variables on top of that, which are physics materials and then the system settings and what kind of gravity coefficient do you have? Are you on the moon? Are you on Earth? Like that kind of stuff, right? So play, experiment. Let me know if you have questions and have fun. See ya.